Hello, YouTube. This is UMills03. I really thought for a while that I was done making Python programming videos. I thought that I had essentially taught you everything that I had known about the Python programming language, and I've already done about 46 or 47 videos that demonstrate tutorials and that sort of empower you to write increasingly complex and interesting programs within the Python programming language. And the integrated development environment that we've been using for that is called PyCharm. And so in lesson 0, we downloaded this integrated development environment called PyCharm. And I showed you how to write Python code within this software development environment. What we're going to do in this video, I thought that there are still probably a few more things that you can still learn about Python. I've already taught you probably about 98% of what I know, but there's other techniques and there's other approaches that you can take to your programming. And I wanted to introduce to you a couple of additional techniques. So there's an additional operator that we're going to talk about, and it's called the Walrus Operator. But anyway, let's get into the context of this video. What I wanted to do in this video is review some intermediate functional programming, okay? There were some lessons like lesson 24, 25, 26, 27. Around halfway through the curriculum, we were talking about intermediate functional programming. And we said basically that there are two types of generators in Python, at least two, but two of them are called map of function iterable and filter of predicate iterable, okay? And they both accept two arguments. They both certainly accept an iterable as their second argument, but map also accepts a function. And we said basically what it does is it generates values. It generates the values of the function applied to each of the elements in the iterable. And so we can demonstrate that with a quick example. What if we had a very simple function here? And if you were a good software engineer, you would go ahead and include some doc strings here. So you would want to provide a little description, a multi-line comment underneath the function header about what the function does, what the parameters are, what is it that the function accepts, and also what is a return, what are the outputs, what are the results of the function call. So anyway, there's a function called 9more of x. So it accepts an input x, and it returns x of 1 plus 9. So if you look at the definition of this function, we've talked previously about how basically the data type of the input has to make sense within the context of the function. So if you say something like x of 1, that already implies that x is not just like an integer. It's not a float. It's not a boolean. It has to be some kind of an iterable. Okay, it might be a string, in which case you would be referring to the character at index position 1. You would be referring to the second letter of the string. It could be a list, in which case you're referring to the second element in the list, right? We said that Python starts at index position 0. So if you say x of 1, that's referring to the second element. But we're going to say return x of 1 plus 9. Okay, so that implies that x has to be some kind of iterable. We have to pass an iterable in, like a string or a list or a tuple, for example, okay? So what we're going to do is we have this an example of map of function iterable. So we say for k and map of 9 more, and then we basically have a tuple of tuples here. So what we're going to do is we're going to pass in an iterable, and the specific type of iterable that we're passing in is a tuple. And what are the elements of the tuple? Well, they happen to in fact be tuples. So the elements of this tuple are tuples, okay? And so basically we have to pass in a tuple into the map of function iterable, right? Because we said that 9 more, it must accept basically a tuple, okay? So that must be the type of input that's coming in, okay? And so with 5 and 35, that's a tuple. So we can do x of 1. So we would return 35 plus 9, which is 44. And that's why you see that 44 is the first element or first output that's printed on the console. It's because that's the first output, right? We say x of 1 plus 9. We say print 35 plus 9, okay? And then we say print 21 plus 9, right? Because now when we refer to x, with the next input in this iterable, with the next element in this iterable, x of 1 would be the elements at the second index position. So that would be not 35 anymore. It would be 21. So we print 21 plus 9, which is 30. So that's why we get the 30 here. And then with this third tuple, we see a 5 here at index position 1, right, at the second index position. And so that's why we say 5 plus 9, which is 14. So hopefully that's clear to you. And then we also talked about filter of predicate iterable, right? And we said filter of predicate iterable is another type of generator, and it yields each of the elements from the iterable as long as the predicate is true about that element, right? So if you say my filter equals, and then you can either do a lambda function or you can do a regular function, but the point is that it has to be a boolean function, right? It has to be a true or false statement regarding each of the elements in the iterable, right? So you could say my filter equals lambda t, and then it has to be a true or false statement about t. So t equals 5 or t equals 8. Okay, that would be a true or false statement. So if it's 5, it's true. If it's 8, it's true. If it's something other than 5 or 8, like if it's 7 or 10 or -15, it would be false, right? So if we say, if we keep up with a variable called how many, for example, like if we wanted to basically parse through an iterable and we wanted to see how many 5s or 8s there were, we could say for a in filter of my filter, and then we could pass in some kind of tuple, right? Some tuple, some iterable that would have 5s and 8s in it. It could be a set, it could be a list, it could be a tuple, it could be basically a dictionary where the values are 5s and 8s. But you can think about different types of iterables, and you could say for a in filter of, and then you have to pass in the predicate and then the iterable. So my filter and then the iterable, the tuple. And you would say every time that it satisfies that condition, every time that for each element t in my iterable, t equals 5 or t equals 8, I want to increment the how many variable. And therefore I print that at the end. And I say that the number of 5s or 8s has to be 3. And that's why you see that on the console, because we had 2 8s and 1 5. So hopefully that's clear to you. In previous videos, we said that lambda functions usually return something. We've already said that lambda functions can have multiple inputs. So we're already kind of familiar that we can write lambda and then x comma y, for example, right? The idea that a lambda function could accept more than one variable. But what we didn't say earlier is that lambda functions don't have to return something. So we've already made a distinction about functions that return something and functions that print something. And in fact, we said that there can actually be functions that do both. So there can be functions that when you call them, not only do they assign, for example, a value to a variable, but they also go ahead and print something to the console. So, usually you would have like a print statement and then a return statement. And then every time you assign a variable to the result of the function call, not only does it make, the variable assignment, not only does it set a variable equal to an output, but it also prints something to the console. But the point that I'm trying to drive home here is that lambda functions can also accept multiple inputs, and also that they don't have to return anything, that they can also print something. So here what we do is we have a lambda function that accepts 2 inputs. And you're familiar with the syntax of a lambda function. Remember, it's all defined in one word. So you say, basically the way that it works is you say function name, right? You say function name, and then you'll have parentheses, and then you can say lambda, and then you can say variable set, variable set. It's just the set of variables that you want to use, and they'll be separated by commas. So you can have 1, you can have 4, you can have 266. But you would have your variable set there, and you just have to name the variables and separate them by commas. And then you would have a colon. And we've already talked about functions that would basically return a result of that. So you could say something like, x plus 2 times y, right? For example, if you had x and y in your variable set, you could say, well, I want the first input plus 2 times the second input, right? You could say x plus 2 times y. And maybe you passed in other inputs too. Maybe you passed in z and w, but you don't even have to use those, right? But you could just say x plus 2 times y as long as x and y are defined within your variable set, as long as they're acknowledged, right? But here, what I'm trying to say is that you can also just have lambda functions that print something. So this lambda function doesn't return anything. It literally just prints something. So what we're going to do is we're going to make a lambda function that doesn't return a result. It just outputs something. So what it would do is it would print length of x minus length of y. Well, what does that imply? That implies that both of the inputs to this lambda function have to be iterables, right? They have to be lists or tuples or sets or dictionaries or strings. We said that a string is basically a list of characters. So we could say basically g equals lambda xy. So it's a function of x and y, right? It's equivalent to if you said define g of and then x comma y, right? You're defining a function of 2 variables. but instead of returning something, the distinction, the thing that I'm trying to point out in this video is that a Lambda function doesn't have to return something, it can print something. So we're going to print the length of x minus the length of y. And what we're implying is that x and y both have to be iterables. Maybe x is a tuple and y is a string. Maybe x is a dictionary and y is a list. It doesn't really matter, but both of them have to be iterables that we can find the length of. And the only 5 data types that we've learned in Python where a length is defined are list, tuple, set, dictionary, and string. So hopefully that's clear to you. And then it says about to test the lambda g function, okay? And then we're just going to run, we're just gonna call the function. So we're gonna say g of, and then we're gonna have a string with 3 characters in it, right? 4, 4, 4. And then we're gonna have a string with 6 characters in it, 3, 4, 3, 4, 3, 4. And those are both considered iterables, right? Because they're strings. So we would do the length of the first string, which is 3, minus the length of the second string, which is 6. And if you do 3 minus 6, you get -3. And that's what's printed on the console. So hopefully that's clear to you. What we're going to do now is we're going to talk about basically how you could basically use the functionality from map of function iterable and filter of predicate iterable to basically do 2 tasks. So what if you wanted to basically take a list of inputs, right? We already know that map of function iterable takes a list of inputs and it gives the output values, right? It gives the function values for each of those inputs. But what if we wanted to filter the list of inputs first? What if we wanted to make sure that the outputs that we were going to provide, that the function calls that we were going to provide, only applied to inputs that met a particular condition? So what we need to do is we need to think about taking an input iterable. We need to think about taking a list or a set or a string, right? A collection of elements where instead of just passing all of them to map of function iterable, we're just going to pass in a select subset. And so what we need to do is we need to filter first by predicate. We want to take a predicate and basically see whether the elements conform, the input elements conform to some predicate, to some boolean, whether some statement is true about them. And then we only want to yield the output of the function for those particular inputs, for those that conform to the predicate. And so that would happen in this strat1 function that I have here. I just wanted to talk about this for a second, but it says to find strat1 of, and then it says function, predicate, and iterable. So it needs to accept a function, right? It's going to basically have a relationship between inputs and outputs. That's a function. Maybe you're just adding 2. Maybe you're multiplying by 2. Maybe you're saying true if the element is bigger than 0, but it's some kind of function. Right? And then you're going to have a predicate. A predicate is like a boolean function. It's just a function that's either true or false regarding a specific element within the iterable. Okay. And then of course the third input that you stick into strat1, this function that we're talking about now, is an iterable. So it'd be a list or a tuple, right? And so, or a string or a dictionary or set. And you would say u equals tuple of filter of predicate iterable. So what does that do? It filters down the iterable. It filters down the set of input elements to only the ones where the predicate applies. And then you can say for z in map of function and u, right? Because u is your truncated iterable. It's basically your subset iterable where it's only the elements in the iterable where the predicate was true. And so you could say for z in map of function u yield z. And that would be a way of basically filtering out the outputs, like the function outputs, for the inputs where the predicate was not true, right? We only want the outputs for the inputs where the predicate was true. So hopefully that's clear to you. But similarly, we could also go ahead and map values and then we could filter the outputs, right? So we've already been talking about how we can take an input iterable and we can just make sure that a predicate is true about some of the elements in that input iterable and then just map those resultant elements, right? The elements, the inputs where the predicate was successful, we can go ahead and map those with the map of function iterable. That's what we just talked about. But what if you wanted to go ahead and apply map of function iterable first? So what if you wanted to apply map of function iterable to all of the elements in the input iterable, and then you wanted to filter the outputs? You wanted to say, well, I've already collected all these outputs, but I only want the ones where a particular aspect, a particular predicate or boolean about that output value is true. And then, so then for that point, you would go ahead and reverse the direction. So you would say strat2 of function predicate iterable, we still have to accept all 3 inputs. And then we would say u equals tuple of map of function iterable. So that would go ahead and map all of the inputs from the input iterable. But then you would go ahead and have to filter it. So then you would say for Z and filter of predicate and U. So after you map all the values, then you would do the filtering. So hopefully that distinction is clear to you, and hopefully you can come up with examples of how you can either filter an input list and then map the resultant values, or how you can map all of the input values and then filter the resultant list. So hopefully that's clear to you. What I wanted to talk about in this video, we only have about 5 minutes left, less than that. But what I wanted to do is talk about a walrus operator, and we only need 4 or 5 minutes for this. But basically, there's another type of operator that we've talked about in Python. And so what we're going to learn about is that we've already learned that basically you can assign a value to a variable, and then you can print the results of that variable, or you can print the variable plus 2, right? It's very obvious to do something like w equals 26. Print w greater than 0, right? And then clearly that would return true because 26 is greater than 0. But the point is that we could declare a variable, right? We could create a variable and then we can use it, and we can do that on separate lines. But the point of the walrus operator is that you can actually go ahead and create a variable and use it, or manipulate it, or get some result of it in the same line, and that's called the walrus operator. And so what we're going to do, we're going to be reviewing this right here, but we're going to say that if we say print of, and then you have these parentheses, what is it that you're trying to print? We're talking about an input to the print function. What is that you're trying to print? That's why I always say print of. But print of, and then you say some variable colon equals some value. And so what is that equivalent to? That actually does two things. So if you say print of, for example, x colon equals 12, that does two things. First, it assigns a variable x to the value 12, and it prints the value of x. So what you would do is you would say that if you say colon equals, it's called the walrus operator. I don't know why it's called that. Maybe the colon sign looks a little like a walrus, but you would say that's equivalent to just assigning the value to the variable and then printing the result of the variable, right? Because once you do the value assignment, then the value should be able to pop up. But basically this does two steps. Not only does it assign the value to the variable, but also it prints the result. And so we're going to do a couple of examples. What I wanted to show you is a couple of examples here, and we just have 3 minutes left. What we're going to do is we're going to use the walrus operator, and we're going to say print of pizza colon equals Hawaiian. Okay, so what does this line do? We can think about a comment here. So remember, with Python enhancement proposals, it's usually good etiquette to have 2 spaces in between the end of your coding line and the beginning of your comment. So now if we go ahead and scroll over here, we can do 1, 2, and you can see 2 spaces here. And then we can have an octothorpe, a hashtag, a pound sign. And then we could say this line creates a variable called pizza and prints its new value. Okay, so that does 2 things at the same time. Not only does it say, okay, I want you to call pizza, I want you to, whenever I say pizza, I want you to point to the string Hawaiian. Not only does it do that, but it also prints Hawaiian to the console, okay? And so that's what it's going to do. It's going to do both of those steps. And I guess to show you that, what I could do, we're running out of time here, but what I could do is go ahead and, delete all this stuff. And I just want to show you that would go ahead and run. So now the pizza variable is defined. And so it's able to print Hawaiian, because not only does it say, okay, pizza equals Hawaiian, but also it says print pizza. So hopefully you can see that colon equals is equivalent to pizza equals Hawaiian and print pizza. So hopefully you can understand that you can do an assignment operation within a print statement. And then what we've talked about is that a string is technically a type of iterable, right? A string is really not that different from a list or a tuple or a set or a dictionary. We can get the length of a string. It's just the number of characters in it, right? It's just the number of letters in the word. And so if you're talking about Hawaiian, what is that, like 8 letters, right? And then you could say pizza.upper. And we were talking in previous videos about how the upper function, if you say string.upper, it returns a string where all the letters of the original string are uppercase. So now if we go ahead and run it, we can kind of compare the outputs here, right? First, we get the result of this string assignment. We get the walrus operator. What we're doing is we're saying not only is pizza assigned to Hawaiian, but we also print the output, right? And we also get the number of letters in that variable. So we also get 8 characters, right? And then we get all of them uppercase because we said pizza.upper. And then remember, if we have bool of pizza, if we have bool of some string, where the string is anything other than an empty string, then we're going to get true. So hopefully that's clear to you. And then this is an example of list slicing. Remember, you should go back to the list slicing videos if you're unclear on this, but pizza of 2 to 5, would print, you know, everything WAI. So it would print the characters at index positions 2, 3, and 4. Pizza.count of I would print the number of I's, and then print of pizza would print the pizza variable. So hopefully that's clear to you, and we'll see more examples in the next video from UMIL03. Thanks for watching, and please subscribe.